Okay, let's find 2 points that are on the graph of this line. First of all, if x is 0, then y is equal to -2. That's the y-intercept. Another point that we can find is when x equals 3, the 3's cancel, so we're left with m of x equals 2 minus 2, which is 0. There's the x and y intercepts of the function m. So that's the first one we needed to look at. Secondly, we need to look at the line y equals x. So those are points where the x and y coordinates are the same, like 0, 0, and 3, 3, and so on. So there's a couple of points on the line y equals x. And for the inverse function, we can basically use the same table we have for m, but with the coordinates switched. So -2, 0 instead of 0, -2, and 0, 3 instead of 3, 0. So now we can graph these three. So we have, first of all, let's graph the diagonal line y equals x. I'll do that one in red. That's the diagonal line right through the middle here, if we use the same scale for x and y. That's the line y equals x. This is 0, 0 here, and then 3, 3. If we go over 1, 2, 3, we go up 3 to get to the graph. Anyway, let's now graph the line m, the function m. So 0, -2 is the y-intercept at -2, -3, so -2 is right about here. And the x-intercept is at 3, 0, so this line goes through these 2 points. So the line looks something like this. Notice the red line is taking a bit of a swerve here. Let's be a little bit more careful about that. So this last line I just graphed is the graph of the line m, the function m. Okay, now for m inverse. I'll graph m inverse in blue here. And m inverse has an x-intercept at -2, -1, -2. So there's the x-intercept of that line. And at 0, 3 it has a y-intercept up here. So this line is coming like this, basically. And there we have, let me make sure this is even more accurate here. This should be right in the middle between them until they actually all intersect at the same point. And there we have it, the graph of the function m, the graph of the function's inverse, m inverse. Let me put that on the graph. This is the graph of m, in the inverse function of m. And notice the symmetry that m and n inverse reflect each other through the line y equals x. Always that's true of a function's graph and its inverse function's graph.